So we come to the last topic of our course, and this is quite easy, but a bit attention you need to put here in this lecture. This is about Moore to Mealy conversions, Moore-Mealy conversions. So between each other we can convert the system. There are two modes of conversion. One happens using the state diagram and the other happens using the state table. So we first come to Mealy to Moore conversion using the state diagram. Mealy to Moore conversion using the state diagram. So here whatever I explain, please pay attention, because Mealy to Moore has its own peculiarities and Moore to Mealy has its own peculiarities. So you have to understand them and then you can work. So here you see the Mealy diagram is given in the left hand side. Here Q1 is the initial state denoted by this arrow which doesn't have anything on it. So that means this is the initial state, and this also means there is no output associated with Q1 actually. But now when you are going to Q2, you have an output 0 coming out if you have an input 0. Again you see in Q2 you also have an output 1 coming when you are going to Q2. So you have to read in this way, that when I am going to Q2 from in this loop, then I am generating an output 1. When I am going to Q2 using this line, I am generating an output of 0. When I am going to Q3 using this line, I am generating an output of 0. Using this line also I am generating output of 0, but using this loop I am generating output of 1. And if I go to Q2 using this arrow, I am generating output of 0. So this is a usual case, right? This is the usual case. So whenever you go to any state, you can either have an output of 0 or an output of 1. In the situation of Q1, there is no such demarcation. That means there is no such output actually. So the output is don't care in this case. So we have not considered any output. However, for the other two states Q2 and Q3, both the outputs are present. The output could be 0, the output could be 1. What we do here, we actually break a state Q into two states. One is Q1, another one is Q0 and another is Q1, with respect to the output that gets generated while we come to Q. So in the Mealy, while we come to a state, we generate an output. So while we come to Q, if we generate an output of 0, then we call it Q0, and if we generate an output of 1, we call it Q1. In this respect, the state Q gets divided into two states, Q0 and Q1. Why this is necessary? Because when I am writing the mood, then I have to associate an output to the particular state itself. That's why it is necessary. So I cannot keep Q as it is, because when I keep Q, I should associate an output with it also. And here I see that it is possible that in some way I come Q and I have generated output 0. In some another way, when I come to Q, I have generated an output of 1. So that special root actually decides whether I am coming to Q0 state or Q1 state. So the thumb rule is this. So without going so much into the understanding what is happening, thumb rule is this: you have to divide any state into two states, Q0 and Q1. If while coming to the state you have generated output 0 as well as output 1, so you have to check all incoming arrows to a state. If all incoming arrows to a state has only same output, then the state remains that only. But if the incoming arrows have both the outputs. So in one of the arrows there is 0, another arrow there is 1. That means this state has to be divided into two states, Q2 0 and Q2 1. That is what we have done here. You see Q2 0 associated with the 0 output. This you can readily do. Q2 1 associated with 1 output. Similarly, Q3 is divided into Q3 0 and Q3 1, and the outputs are associated immediately. Now we have to associate the arrows. The arrows are very simple to now fix. So you see from Q1, where are you going? You are going to Q2, that is true, but generating an output 0, that means you are basically going to Q2 0 with the input 0. So what would be the arrow here? This. With input 0 you are going to Q2 0, the output generated is 0. From Q1, when you are giving input of 1, you are going to Q3 0. So you are going to Q3 0 with input 1. When you are at when you are at Q2, where are you going? When you are giving output 0, input 0, you are going to Q2 1. Now here is the actually some confusion. So you are starting from Q2, but here there is no Q2 state. What to do? Both Q2 0 and Q2 1 are basically the Q2 state. Only their outputs were different. That's why you have demarcated these states differently. So when you are looking at Q2 0 here in the Moore diagram, you have to see the Q2 state in the Mealy diagram. So when you have asked the question that from Q2 0, if I have given the input 0, where I would go, you have to look at the Mealy diagram and see that when you are at Q2 and you have given 0, where you are going. So when you are at Q2 and had given 0, you are coming back to Q2 generating in output of 1. So you are basically going to Q2 1. So this would be the arrow. For 1, you are going to, when you are given 1 to Q2, you are going to Q3 0. So this is for 1. Similarly, same thing you have to do for Q2 1. So when for Q2 you are given 0, you are going to Q2 1. So it is a self loop for 0 in the case of Q2 1. And when you are giving 1, you are going to Q3 0. So this is again coming here. What about Q3 now? Q3, you see, when you are giving 0, you are going to Q2 0. So from Q3 0, if you are giving 0 input, you are going to Q3 0. If you are giving 1 input, you are coming to Q3 1. Q3 1. Similarly, in Q3 1, if you are giving 0 input, you are going to Q2 0. Like this. And when you are giving 1 input, it is a self loop. You note one thing, when I am drawing the state diagrams, I am being very careful that I am not crisscrossing the loops, crisscrossing the arrows. So I am taking arrow from this side so that I don't have to crisscross the arrows. So always try to draw the state diagrams in such a way that you don't need to crisscross the arrows. If at all it is unavoidable, then you have to make a loop. This sort of if this sort of loop you have to make if it is situation is unavoidable. Otherwise you always try to go around in circles or whatever so that you reach without overlapping or without crossing another arrow. So this I think I had already drawn before, so this is the result. This is Mealy to Moore conversion. I hope this is clear. We look into the Mealy to Moore conversion from the state table. So this is a conversion when the state diagram is given. When the state table is given, what to do? Very easy. You can very clearly see what is the output associated with the next state. This means when you are in Q1, you are going to Q2 generating output of 0. That means you are going to Q2 0 basically. So that is how you rewrite the entire state table. So simply note the output associated with the next state. You only give that 0 0. That's all. That's all you do. For Q2 has changed to Q2 0, Q3 has changed to Q3 has changed to Q3 0. Here Q2 has changed to Q2 1 because the associated output is 1. Q3 is changed to Q3 0. Q2 is changed to Q2 0. Q3 is changed to Q3 1. Perfect. Now you have to rewrite the state table because now you have so many number of states. New states have come. So you have to rewrite the state table with all these states. Q1 is already there. Q2 0, Q2 1, Q3 0, Q3 1. And then you again rewrite based upon the next state for u equals to 0 and u equals to 1. What is the next state for u equal to 0? It is Q2 0. For u equals to 1, it is Q3 0. What is the output for Q1? The output is don't care, because you see there is no associated output obviously for Q1, so it is don't care. Then Q2 0, the next state is, you have to look at Q2. You have to look at Q2 when you are deciding for Q2 0. So for Q2 0 and Q2 1, the state of next state will be same, you see, because both are actually Q2. So the next states will be same. However, the outputs will be different. That's how these has been separated because of the output. So for Q2 0, what is the output? You don't have to look at the state table because it is already shown here. The output is 0. For Q2 1, the output is 1. Similarly for Q3 0, output is 0. Q3 1, output is 1. For the next state, you have to see what is the next state of Q3 in the Mealy table. That's all. So Mealy to Moore conversion using state table is also possible, not very difficult. Now comes Moore to Mealy conversion. In Moore to Mealy conversion, there is no addition of states. So there was one difficulty in Mealy to Moore conversion. We had to introduce new states. But for Moore to Mealy conversion, you would suppose that we have to shrink states. We have to reduce number of states, but that is not what happens. The number of states remains same. It is very easy from the diagram side. What you simply need to do is basically move the outputs. So I will use another term which might be easier for you to understand. Back propagate the outputs along the arrows. Back propagate the outputs along the arrows. That means you have an output 0 here. You take this 0 to the incoming arrow. That is back propagating through the arrows. So you take this 0 to the incoming arrow. You take this 0 to all incoming arrows. Here again you take this 0 to all incoming arrows. This is the only arrow incoming. Here you take this 1 to all incoming arrows. That is what we have done here. And now if you read the diagram, you would see that the result will remain same. Let us take only one example. Here from Q2 you are going to Q3. So in the Moore diagram, when we are at Q2, you have received an input of 1, you have gone to Q3. When you have gone to Q3, then the output becomes 1. In this case, from Q2, you are going to Q3 with input 1, and while going to Q3, you have generated an output of 1. So it seems that the output, the exact moment of the output is a bit ahead in Mealy circuit than in the Moore circuit. In Moore, we reach the state and then the output happens. In Mealy, the output happens and we reach the state. So this is what happens actually. But the output and the state combination is same for the given input. And you can check this for all the other arrows. You should check that this is exactly what is happening. So the simple rule for Moore to Mealy conversion using state diagram is back propagate the outputs in the arrows, or in other words, take the output and associate it with all the incoming arrows. With the help of state table, how would you do it? So let's see, this is the Moore state table. From the Moore state table, you have to actually form a Mealy state table. How you are doing it? This is also very direct. So how we have done it? So you see, your next state is there, okay, and some output is there. This output is not associated with the next state. This output is associated with the present state. When you are drawing the Mealy state table, the output needs to be associated with the next state, not the present state. But what would be the output for Q2? You have to look at the output for the present state Q2, which is 0. That's why you see, whenever you have Q2 in the next state, your output is 0. That 0 you have taken from this information. Present state is Q2, output is 0. So here also, when the next state becomes Q2, your output must be 0. So that is what you are indicating here. When your next state is Q3, what would be your output? Let's see in the Moore table, what is the output when my present state is Q3? The output is 1. So when my next state is Q3, my output will also be 1. When I am at when I go to Q1, when my next state is Q1, what would be my output? So Q1 is here. So we have to look at output when the present state is Q1 in the Moore table, and that we assign here. So it is simply an adding of one additional output column, and that output column we fill up by looking at the present state and the output columns of the Moore table. That's all we do. So it is much easier. Okay. So this completes the entire course that we have to cover, and I hopefully all these topics and the concepts are clear to you. And if you have any doubts or anything, you can always ask me, and we can always arrange some additional classes to clear those doubts. So anyway, thank you for your attention.